Hello everyone, welcome to my YouTube channel. So we want to see the derivation of the formula for differentiation, first principle formula, where we have that dy dx is equal to. So how do we go about this? Now, if we look at the formula, the graph we have here, this is the function that we want to find its derivative, the f of x, that's the y function. Okay, so and whenever we want to look for derivative of a function, we look for it at a particular point. So we are assuming that we're looking for derivative of this function at point x1. All right. So now we know that y is equal to f of x. And so if y is f of x, it means that y1, which is this one here, is actually a function of f of x1, while y2 is a function of x2. Okay, and then from here we can see that our x2 is actually x1 plus change in x. Okay, so and you can actually see that change in x is equal to x2 minus x1, and so from here we see that x2 alone is equal to x1 plus change in x, and this change in x is what we also called h here. Okay, so I can actually write this as x1 plus h. Okay, so and then the implication is that I can actually write this as f of, since my x2 is x1 plus h, so I can write it as x1 plus h. Okay, and now my derivative of a function is written as dy dx, and by definition is actually equal to the limit of the gradient of that function, the gradient of the function that you have as the change in x, which is the denominator, tends to 0. So we should take note of this definition. Okay, and so what is the gradient of a function? So we are given here, we know that change in y all over change in x is equal to y2 minus y1 all over x2 minus x1. And from what we have here, we can make some substitutions here. So this means that is equal to our y2 we have as f of x1 plus h minus our y1 is f of x1, and this is all over our h, which is change in x. Okay, so if we introduce this limit on this gradient, it will automatically change it to dy dx. So let's quickly do that. Okay, so then when we're introducing the limit, we would have to introduce it on both sides. So we have the limit of change in y over change in x is now equal to the limit of, remember I said this change in x is also called h going to 0 of the whole of this. So that will now give us f of x1 plus h minus f of x1 here all over h. And remember I said that this is actually equal to dy dx. So I can actually change this. So I can change this to dy dx, and then I'm going to have that my dy dx is equal to the, now, but this is the derivative of this function at point x, x1, sorry. Now, but what if we want to find the derivative at an arbitrary x? Okay, so we're going to then replace this x1 with an arbitrary x, and that gives us the final formula, which we have our dy dx to be equal to the limit as h goes to 0 of f of x plus h minus f of x. Remember, I'm replacing x1 by just x, an arbitrary x, and that is the required formula for differentiation. This is the formula for differentiation by first principle, and we can actually use this formula to get the general formula of differentiation of a polynomial, where we say that dy dx, that if y is equal to x raised to power n, then dy dx is nx raised to power n minus 1. And of course, we are going to see this in later videos where we'll talk about differentiation by general principles. Okay, and that's where we're going to stop. Kindly subscribe to our YouTube channel, and we'll see you in our next video. Bye.